All right, welcome back, Hononegah Honors, Algebra 2, Section 2.2. We're going to divide this up into 2 days, but we're going to talk about different characteristics of quadratic functions and some different things about quadratics. There's really 3 forms that we'll be interested in, and the first form we've talked about a lot, and that is vertex form. So right here, that is vertex form, but axis of symmetry. Axis of symmetry is a line that divides a parabola into a mirror image and passes through the vertex. So looking at this picture over here, you have a parabola, and so the line that cuts it symmetrically is known as the axis of symmetry. So again, the line that cuts that in half symmetrically. It always goes through the vertex, and so therefore it's a vertical line. If it's an up and down parabola, it's a vertical line of x equals h. And yes, you need the x equals, because if you just said 3, then I wouldn't know how to graph that. But if I said x equals 3, then yes, I know how to graph that line. So it's a vertical line at 3. So again, axis of symmetry. Now, the next page is going off your notes. So just put your notes down for a second and watch me. There's a shortcut that I keep referencing, and I say that if you're in class, maybe I'll show it to you. And I decided that I really do need to show you the shortcut. Just like when you are graphing a line, if you know the slope and the y-intercept, you can graph it. So if you know the vertex and the a value, you can graph it. So I'm going to go back to a normal basic y equals x squared parent function. So the a value here is 1. So this is the most basic function. The vertex would be at 0, 0. Now, you ready? If I go over 1, I always go up 1. If I go over 2, to the right 2, I go up 4. If I go over 3, I go up 9. So if you are thinking about that just a little bit, so you're saying if I go over 1, it goes up 1. If I go over 2, it goes up 4. If I go over 3, it goes up 9. You'll notice a pattern there. And it's always 1a, 4a, 9a. And in this case, the a value is 1. So there's a lot of things to think about there. But it means if I go over that many, I'll always go up or down 1a, 4a, 9a when making my next point. So let's do another one. And I'm going to make my a value 2. So x plus 1 squared minus 3. So the vertex is at -1, -3. All right. My a value is 2, which means if I go over 1, I would go up 2. If I go over 2, I'm going to go up. Remember, it's 1a and 4a, so I go up 8. Okay, so I went over 2. Maybe I should draw over 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's how I'm creating my vertex. It's always 1a. So I go over 1, up 1a, or down 1a. If I go over 2, I go up or down 4a. And if I go over 3, I go up or down 9a. So I'm going to do one more, and then we'll get back to actually taking notes. I'm going to go -3 x minus 4 squared plus 7. So my vertex is at 4, 7. So I'm going to put a dot at 4, 7. All right. If I go over 1, I'm going to go 1a. So over 1, down 3. If I go over 2, it's always 4a. So if I go over, and I'm going to draw the over 2, I'm going to go down 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Put a dot. So again, that is the shortcut method to graphing a parabola. Is always go 1a, 4a, 9a, as long as you know the vertex. All right, back to the actual notes. So the vertex in this particular case is -3, 4. The axis of symmetry, the line that's going to cut this in half, is going to be x equals -3. So let's graph this. I'll come back to the y-intercept in just a second. So the vertex, -3, positive 4. And I'm going to use the shortcut method to graphing here. Let's see if we can do it. If I go over 1, so left or right 1, I'm going to go down 2, because that's 1a. If I go over 2, I'm going to go down 8, because that's 4a. 1, 8. And that is the graph of the parabola. You could do an XY chart. I am not going to stop you from doing an XY chart. Just watch what happens if I were to do an XY chart. So if I plug negative 2 in, I would get 2. If I plug negative 1 in, I would get negative 4, which happens to be the exact same points that I just graphed over there. So using a graphing calculator and typing that in would also be and use the table function. Now, it's asking me where would it cross the y-axis, and this is kind of an inappropriate question for intercept or for vertex form, but if I plugged 0 in for x, what would you get as the y value? So if I plug 0 in for x, so I get negative 14. So it crosses the y-axis at 0, negative 14. And again, that's probably not an appropriate question necessarily for vertex form, but it's way more important in standard form. Speaking of, here's standard form. So we have our second form now. This is a new one. Y equals ax squared plus bx plus c. If you have something in standard form, you need this formula right here. Write that down. Very important. The axis of symmetry formula for standard form is negative b over 2a. That will allow you then to have the x value of the vertex. Because once you know the axis of symmetry, then you also know the x value of the vertex. So the equation of negative b over 2a, or excuse me, x equals negative b over 2a, is a very important formula for graphing standard form. All right, so here we go. It's in standard form. So I need x equals negative b over 2a. The a value is always the number in front of the squared term, the b value is always the linear term, and c is always the constant. So I have negative 6 over 2 times 3. So negative 6 is positive 6, over 6 would be 1. So the axis of symmetry is x equals 1. That means the vertex has a 1. Now, plug 1 in for x to find the vertex. Square before you multiply, order of operations, so 1 squared times 3, I get negative 2. Remember what I said before, if I know the vertex, I can go 1a, 4a. So if I go over 1, I would go up 3. Sorry, my board is having some issues here. Give me 1 second. There we go. So over 1, up 3. Over 2, 4a would be up 12. So if I go over 2, 12. Again, an XY chart is appropriate. If you'd prefer doing the XY chart and having trouble with the shortcut method, by all means you should. The y-intercept. Now, the y-intercept is always the c value in standard form. Now, it has to be in standard form. So if we put 0 in for the x's, just like you did in vertex form, you will always get c. And if you looked at the picture, you would notice that it does cross the y-axis at the point 0, 1. So that is standard form. Last form that we have is what's known as intercept form. Intercept form, when a graph in a quadratic form has at least one x-intercept, the quadratic can be written in what's called intercept form. The p-value, and let me try this again. The p-value and the q value in this equation are the x-intercepts. So it has an x-intercept at p0 and also has an x-intercept at q0. We'll talk about then how to come up with the vertex when in something is in intercept form. So this is basically saying the same thing. Now, the equation for the axis of symmetry is always x equals whatever the p value is plus the q value divided by 2. That is like taking the average. If I know where p is and I know where q is, the line going in between them is the axis of symmetry. So think about this. If I had the point 1, 0, and I had the point 5, 0, then 1 plus 5 divided by 2 is 3. So the axis of symmetry for this particular situation would be x equals 3, because you've basically drawn a line in between the midpoint of those two values. All right, so I have something in intercept form. Find the intercepts. So what value makes that 0? Well, -3 makes that 0. +1 makes that 0. And yes, you have to write those as points. So -3, 0, +1, 0. Now, what is the halfway point in between? That is where the axis of symmetry lies. So if I add the p and the q and divide by 2, I get x to be -1. So there's a line. I'm going to do this in a different color. Okay, right down the middle, that's the axis of symmetry line. This also tells me that the vertex is located somewhere at -1. Plug -1 into the original equation to find the vertex. So -1, 3, or -1 plus 3 would be 2. -1 minus 1 would be -2. And so then you get +8. Now, we didn't talk much about this previously, but why did I know this parabola was going to go down instead of up? Well, I knew that because the a value was negative. If the a value is negative, it's a downward parabola. If the a value is positive, it's an upward parabola. So I know this just by knowing the a value in front. Because the vertex is the highest or lowest point on the parabola, the y-coordinate is considered the maximum value or minimum value. The vertex lies on the axis of symmetry, so the function is either increasing on one side and decreasing on the other. So now, I believe I have a picture here. So this vertex is the minimum of this parabola because it's the bottom of the parabola. Whatever the y value of the vertex is actually considered the minimum value. Now, you always look at this from left to right. So this, it's going downward on this side, so that's decreasing, and upward on this side, that's increasing. So it's like riding a roller coaster. It's going downward on the left and upward on the right. So the left would be decreasing and the right would be increasing. This next one has a maximum value, top. This side would now be increasing as it goes up, and this side would be decreasing as it goes down. So again, you're looking at it as like a roller coaster from left to right. So the left side here is increasing and the right side is decreasing. All parabolas have the same domain. It's all real numbers. I shouldn't say all parabolas. All up and down parabolas, or y equals parabolas, have a domain of all real numbers. The range is always greater, if it's an upward parabola, greater than the minimum value. If it's a downward parabola, it's always less than the maximum value. So this is the minimum, and this would be a maximum situation. All right, so let's actually do a question here. Find the minimum or maximum value of a parabola in standard form. So let's talk about standard form again. X is equal to -b over 2a. X is equal to -2 over 2 times a half. So I get x to equal 1. I'm sorry, x to equal 2. That is your axis of symmetry. Now, let's actually find the vertex then. 2. Plug 2 back in for x. So a half, 2 squared, 2 times 2, minus 1. Remember, always square before you multiply, so 2 squared is 4, times a half would be 2, minus 4, minus 1, so I end up getting -3. without even graphing this parabola. Can you tell me whether or not this parabola goes up or down? Well, the a value in front is positive. So this parabola is going to go up. That means something. So what is this? A max or a min? Because it's at has a bottom, it has a minimum, and the minimum value in this case is -3. The domain is all real numbers. You can abbreviate that. And the range would be y is greater than or equal to -3 because it has a minimum. So all the y values go up from -3. Now, again, looking at my little sketch, this side would be decreasing, and this side would be increasing. So it is increasing on the right-hand side of the parabola, and it is decreasing on the left-hand side of the parabola. The parabola in the picture shows the path of your first golf shot. So the picture is your first shot, where x is the horizontal distance and y is the corresponding height. The path of your second shot is f of x is equal to -0.02x, parentheses x minus 80. Which shot travels farther before hitting the ground, and which one's higher? So I can look at my picture here, and I need to move this so you guys can see it a little bit. The first shot went 100 yards. All right, I'm going to apologize for the interruption there. The first shot then on the picture went 100 yards, and then it went up. After 50 yards, it was up at 25 yards. So again, that's the picture is your first shot. So now your second shot, we need to find the vertex. And this is actually in intercept form. It's just a little harder to see it because it's x minus 0 and x minus 80. So 0, 0, and 80, 0 are the intercepts. So then the vertex would be 40. So I would plug 40 in for x. So -0.02 times 40. So -0.02 times 40. And then 40 minus 80. So now using a calculator, I would get 32. So the next one has a vertex at 40, 32. So now which shot went further? Well, this shot went from 0, 0 to 80, 0. So that shot only went 80 yards. So the first shot went further. Which one went higher? Well, the second shot went up to 40, 32. So again, a little bit higher loft, went up higher. So we're talking this one, the second one actually went higher. So that is the end of the section. If you have any questions, please make sure that you talk to your teacher, and good luck.